Okay, thanks. Good. Please go ahead.
So, the topic of the presentation is database for digital infrastructure of small modular reactor, considering dynamic subject area. Outline. Introducing and motivation, analysis of SMR, dynamic infrastructure, and requirement of to database, method of DSA formation, considering the practicalness of SMR systems, result of analyzing DSA, and suggestion on developing and integrate database for SMR. So the analysis of small modular reactor project in USA, Canada, and European countries confirm the properties for developing advanced critical energy infrastructure. SMR projects entail the establishment of digital infrastructure and the incorporation of new information technologies, including databases. The utilization of SMR necessitates a short-form classical database with a static subject area to databases with dynamic subject areas. The dynamism of the subject area requires accounting for changes in domain objects, both over time and in space, and necessary the developing appropriate mathematical models for SMR and energy grids. Authors of a method of data collection in nuclear power plants, nuclear technology article address 15 data source in nuclear power plants and methods for transferring data collection from manual and analog formats to automated and digital forms, thereby enchanting data accurately over time and space. It's kind of reactor monitoring systems, maintenance logs, etc. So let's look at the SMR DI structure. On this page, you can see next structure. Head of this system of exchanging and processing information of crisis center, SPICC, that's one. Here it communicate all of neighborhood systems like communicate with consumers, energy grid, with small modular reactors, maybe one, maybe another, maybe a bunch of, and with the system for control. fleet control system or system of radiation control. That's one. This system we can separate for database data. I mean, database are essential component of the SMR DI. In the structural diagram of SMR DI database are included the systems of exchanging processing information of crisis center, system of contemplation management, supervision, information and control system, and UFCF, fleet control system, forming a distributed database structure. So at existing nuclear power plants, data is controlled to solve task release 2. Forecasting the future potential characteristic, functional capabilities, and service life of components required to ensure continued safe operation, making the decision of the type and timing of preventive maintenance, including repair and replacement, and detecting and assessing the degradation, fail, and malfunctions of components caused by aging and other factors. Requirements to databases. According to this task, we can separate three following types, three categories. Category of one is the initial information consisting of design data and conditions at the beginning of the component's service life. Second, data from operational history, and compressing maintenance condition at the system and component levels, as well as data on component availability testing and failures. And third, data from the history of technical maintenance, including data on monitoring and condition support of component, parameters of monitoring operation conditions, type of repair or maintenance description, and so on. According to the new capabilities of technologies, it is possible to add new types of the existing data types. States of physical and information security of SMR, data on system behavior, a combination of data of critical parameters sent to the inspector, and then for preventive maintenance. Data of radiation levels obtained from drones and robots, knowledge or data present in the form of facts, rules, expect, jumps, then can be applied when making decision in a crisis center. What new we have there? New data types are dynamic in space and time. Porter representation or in databases. Traditional databases are known for their static and ambitious nature. Building a database involves creating conceptual logic and physical models subsequently. A significant drawback of current classical database technologies is their inflexibility in terms of the number of subject area, objects, attributes, and relationships. Users typically lack access to the conceptual, logical, and physical database models, preserving the database is a black box. Changes to any database model can only be executed by administrators, and any alternatives in the number of subject area, objects, attributes, and relationship necessitate redesign of the conceptual, logical, and physical database models. Method of dynamic subject area formation. We can separate 10 methods. We separate automatic subject area updating, processing caching data, flexible data models, dynamic inheritance and typing, handling heterogeneous data, version and compatibility management, system behavior evolution, system self-adaptation, detection and resolution of incapabilities, data security and integrity. So on this slide, you can see a table for comparison of DSA method with possible variants of dynamic changes of database elements. For elements of the integrated database, it is necessary to consider the ability for dynamic changes in the composition of object of subject area, as well as changes in their attributes, data types. It should be noted that the proposed methods for dynamization of subject areas can be divided into two separate groups. First of group method that take into account changes in the composition of objects in the subject area, their properties and parameters. Method then consider changes in the attributes, data types of object in the subject area. a result of analyzing DSA and suggestion on developing an infrastructure database for SMR. The table present various dynamic change options proposed for implementation and different types of database used in the components of the integrated database of MMR. The next step is create the table provides a list data structure characteristic of the subject areas and potential method for forming dynamic subject areas for this database. Conclusion. The primary contribution of the research lies in developing comprehensive structure for the database, taking into account its system important aspect, the potential for external interface in the operation of the power system through cyber attack, personal errors, and environmental influences. Priority should be given to analyzing potential changes in the subject area due to external influences to determine the level of dynamism for the CI information system. There are numerous methods for creating dynamic subject area through different types of database, which require a few further investigation. The question of the relationship between different types of database and method of dynamism the subject area requires careful consideration. Yep. Oh. Thank you.
Thanks, Dmitry, for your presentation. And now we have time for some questions. Colleagues, do you have any? Okay, Amir, please ask a question.
My question is, I have worked on speeding up the mode calculations, and one of the bottlenecks I have discovered is the data transfer speed, particularly over the internet. Modeling large electrical networks requires a lot of data, and it's very slow to pass it around. And so as a result, I personally reverted to using an in-memory database on self-hosted servers. But I'm curious, maybe you do have a solution for this problem, or maybe a direction for a solution. Because in your requirements, you didn't mention anything about the speed of the data transfer.
Yeah. I want to show you this picture. You see a block with customers. I mean, if we use the different database for collecting information of using electricity and have enough data for making decision. I mean, if we collecting a lot of data of using electricity systems, we can know in future very interesting information. What we does know now, if we use dynamic database, we can select different information about using electricity, and then we can solve issues what we can solve it before, because now in time when big data can solve a lot of problems what we have before, I can suppose that fortunately we have this chance in future.
All right, thank you.
Dmitry Maevsky, please go ahead.
Dmitry, first of all, thank you very much for your interesting presentation. This topic is really interesting for me. But I have two questions to you. First question is, it seems to me on slide number 4, you have said about 15 data source.
Yes.
Where did number 15 come from? Why exactly 15, not more nor less?
This is question for people who created this article. I mean, we use it article people who created, who making some work and write articles where write 15 data source, but they right, okay, we selected this one, this one, but they didn't say where we save this data and where, I mean, what kind of database we use it for this data, this point of our work. Yeah, it's been 15, but benefits of this work, it's mean this can be more than 15. This can be dynamization and increase such as you want, and you have no hard relation for 15. I mean, this is like a example.
Thank you, Dmitry. And another question. We compared 10 dynamic subject area methods according to only 3 criteria. Are there any other criteria for comparison?
Yes.
Yes.
If we added more if we added more centers of processing data, we can add more criteria for them. Why not? I mean, maybe I should correctly understand your question.
But maybe criteria number 4 exists, and we will have some any table with some any results. Some other table with some other results. Sorry.
This we have no hard resist for you can see, for example, on this picture, you can see database SCM. We can use from one kind of dynamization to 10. It's we can select any of this any of this area, any of this concept, and use it there.
Thank you.
Yeah.
May I ask? I have two questions. The first one is, what problem must to help or solve the digital infrastructure system?
Mm-hmm. For example,
not for example, please formulate the name of the problem.
Name of the problem: save data. Select the. Yep.
Okay, for what do you think, for what we must develop the data infrastructure for small modular reactor or any other nuclear power units?
For what? For power. For give power, I mean, for people, I don't know. If you have a
okay, more simple question. My next is the exploration company decide the problem of preventive maintenance or preventive repairs of the nuclear power plants. And in order to do so, it is necessary to collect and to use for forecasting, for estimated the conditions of nuclear power plants. And you must to collect the data concerning the repair works which done and what time this works done and similar data. Listen of your presentation, I cannot find these specific information that must be collected.
Yeah, in this article, I give not the database, for example, for collect information from customers or collect information from robots or another data, but we try to analyze what.
No, I asked about. Yeah. I'm sorry. I asked about the specific information concerning the timetable of repairs. The repairs play important role in the nuclear production, in the nuclear exploration company. That must be guaranteed correct work of the power plant and the safety of the nuclear power plant. And for achieve this, it is necessary to prevent maintenance, to prevent the work. Yes. Previously, before the dangers happened. And yes. During this work, it is necessary to fix it. The information concerning these repairs the timetables and the specific of didn't work and so on.
But not all of them information what we have, we should write to relation tables. I mean, we can select another databases, not only one of, and that's all. I mean, if we need select information from customers to
No customers.
analysis, how a lot of we should get, or if something happen like don't care, forget what. Not all of them, not all of the information what we have from SMR, we should preparing in relation tables. We have different now. We have different database. We have dynamic databases. We have any approaches for updating. Code base, for example. It's not about collecting information. It's about dynamic support the SMR. I mean, we use the same rule, or not rule, the same main structure for use of this SMR in east or west, but we have preparing preparing information, of course, before we developing nuclear station. We preparing information, yes, and for new places we preparing new. This is city provides needed. That's one power. That's another different information. And with time, with continued time, we have more and more information. So we redevelop, renew again and again software on this SMR or on database. But usually it has a lot of time, and if we use this dynamic, why not? It's it saves our time.
Oh, okay, colleagues, we're a little bit running out of time. Let's please keep your question to Dmitry to the end of the session. Vyacheslav, you have some comments, question right now?
Yes, very short comments, because a few questions which was asked by Sergei Sauch. I very shortly comments.
Yeah, please.
About this work. In this work, we analyzed just possible architecture of databases as a part digital infrastructure of CMR. And plus, next step is the application of big data analysis for different issues. We have 3 databases: technological, technical state, in point of view maintenance and predictive analytics, and security issue. We have additional separate presentation where aspect of predictable maintenance and testing are developing, taking into account the features of complex equipment of SMR, electrical, mechanical, and so on. And in this case, we use network-based testing means to take into account changing and to assure flexible procedure of maintenance. It's my very short comments to your question. Thank you very much. I think your questions are very important for us, for Dmitry, for next steps in this area. Thank you.
Thank you very much.
Okay, colleagues, let's go ahead. The next